Thank you, Jerome, for this kind introduction. So it's the last roundtable. We are focusing on the actual systems and difficulties in doing physically what we heard yesterday and today as being the prospects. So our discussion today, we will mirror the roundtables 1 and 2 on where we stand today, both in meeting the customer expectations, which was the issue of the roundtable 1, and also where do we stand today with the use of technologies, because we heard about a lot of technology perspective. What is the status today? We will discuss together the actual opportunities and difficulties with AI implementation in system design, but also in system deployment in operation, because a prototype is good, but what is it when it's on the field? With several examples. This will address particularly several topics, not limited to. The access and sensibility regarding operational data. We spoke about this a bit in the second roundtable, but it's a very important point, taking into account the relevant operational expertise and also the difficulty of the transferability of the tactical know-how of the end user, because we are in the military area in a field where what we aim at with AI is improve the operational tactical efficiency. But this is a kind of something that the operators want to keep for themselves. So what is the part of, what is the good way of sharing? And it's like in your personal life, sharing is good. Nobody wants to share his position everywhere with, I don't know who, Google or anything. But as I get a good service, I say, okay, I will accept to transfer part of it. And in the military area, this point is very crucial. Disparities of development regarding onboard and on-ground solutions, because technology, AI technologies, modern AI technologies are demanding, we saw it yesterday, a huge computing power and a huge bunch of data, which are not compatible with onboard hardware capacity. The difficulties are about defining new uses, because we said AI is new, we have to think differently, and we have to act differently. And the articulation of new functionalities relating to AI, and which goes together with it's the human factor aspects, including bias, because when you train on simulators, as Philippe was talking today, it's a good way of providing a huge bunch of data, but simulators have their own bias, because, for example, sensors are more or less perfect in a simulator. Not the noise is very, very low. And yesterday, Pierre-André asked the question about how to get the training with the noise and not without noise. Before letting the ground to my colleagues here, I will start with my own perspective. So within Dassault, I will set three examples of the different ways to use AI. The first one is how to use the AI, the civilian AI world with its full capacity with military data. We have an example, operational one, for maintenance data. Maintenance and predictive maintenance was cited earlier as a good example for using AI algorithm. So in the Rafale, I will illustrate on the Rafale project, because Rafale is an operating system. It's not the future. We build, as Philippe said, very ambitious project for the FCAS. But the first ground player and tester for all these collaborative combat systems, AI utilization, or what for the next 20 years will be the Rafale, and not the future fighter. So in the Rafale, for the maintenance area, we have data stored for 20 years, since 20 years on the maintenance data systems in the French Air Force. And in the recent total program maintenance, which the English name for that, it has another name in France, for the Rafale, it was decided to move all the data in a single data information system under the administration responsibility of the OEM, Dassault Aviation, but with the rules for dissemination of the data to each one of the owner of particular data. And it runs on a cloud-based solution external to the Army. And this cloud-based solution is directly on a private cloud, but directly coming from on a commercial-based cloud solution from Dassault system. And it proved efficiency by, so the result is simple for maintenance is, do you increase the operational availability of your fleet? And it gives the first results. And what is interesting is how do you, there are AI tools in this environment, but the question is, how do you use them? And if you make a query, a classical query for data in maintenance, then you get the same results as before, because the data in question, if you ask a simple query, the data are coming from analogic equations. So then if you query them with an AI algorithm, he will give you some results, which gives you confidence in the system. But after that, what we expect from as benefit is to have other queries trying to keep to take the weak signals. And this is also another competence, is how to get the good query. This example is good, but then we will move to operational world. And then there is a big challenge, is because we are able to do that because the maintenance data are not secret. You extract a set of data that the Army is not, well, it took us 2 years to discuss with the French Air Force to accept that the data comes out from the military world to the cloud in the industrial world. This is not possible with operational data. And the operational data, it brings me to the second example. Second example is what is the story we have with IA, starting from the old IA, as we learned in school with the cloud. So we developed since decades algorithms with classical AI, I mean neural networks and statistical queries or exploration of with a simulation. So the simulation are based on the physics equation, but you make a stochastic evaluation of combination, and we develop a tool for evaluating the combat efficiency. So systems classically are system function in the old world are designed for a single aircraft, a single pilot, and performance. But then they are operated. What does it mean if you have 4 aircraft against 8? And this is not specified as such in the function. And then we have since a long time engineering tools based on AI to explore the behavior of our systems in a multiple actors situation. This was developed for that, for the aircraft, Rafale aircraft air-to-air functions. Then moved this type of function to establish in the Franco-British FCAS systems to try and plan the better trajectories for a set of drones, 4 or 5 drones having an attack mission and against a difficult environment. So again, using this AI type of exploration to determine in real time the best trajectories. But this was real, I would say, geek engineer tool. Then in 2020, we decided to move to use this type of tool to get, I would say, advice to the collaborative combat mission for complex mission that the French Air Force has, including the most difficult one, which is a deterrence mission, which involves plenty of actors. And then we decided to ask the French Air Force if they were happy to test this type of tools to try and improve the efficiency of the collective mission. So they accepted that. We tried to go embedded with the French Air Force on very complex exercises and use this tool to try and get with them better tactics. And then we are faced to how do you make this type of tools used by operators? Because what they want then is says, okay, this is good, a tool, but I want to use it on my own without you. And then you have to transfer this type of complex tool to users. So it's really something that we are addressing now. And then it's how to train this, because today it's trained only with simulation, engineering simulation. And then we are agreeing in the Rafale project, as Philippe was saying, on the simulation, but not only on the simulation, because today on such collaborative complex mission, already with current system, you have to simulate, then plan the mission, execute it in a training exercise, rehearsal or do the mission, see if it works correctly or not, see where are the difference between what you expected and what was happened. So to train the people, which is a collective training, very different from the training in one pilot in one simulator, and get, so what we expect on of IA functions is to enhance the capacity of such tools with the learning of what is done on the field. So we have to go with this, what we heard earlier, to this data system, getting all the operating data and merging all of them in the military, so such a military cloud, and be able to bring AI tools to this type of cloud, which is not easy, technology speaking. Because AI, as you said, AI capacity are evolving very quickly in the commercial area, and how to get this quick advance on real time inside defense cloud. So these are two examples of where we stand with using actual AI capacity. So then I think I over time now. It's okay, Jerome? Okay. So it's easy because two of our speakers today have already been presented, including Pooja, which is our golden guest today because she's participating to all of the three roundtables. So I will start letting the word to Christophe. Christophe was already presented as a system architect with Thales for AI complex solutions. Christophe?
So you want me to start about these current transfers and next time issues?
Yes, it's so the way we do is each of you present his own perspective, and then we go to the questions and debates among yourselves.
Yes, perfect. So thank you again for this opportunity to talk a little bit to that community. So first, I would like to make some examples, of course, because we are discussing current transfers. So it's better with examples. But first, I would like to say that there are many possibilities to present or highlight things that happen within a group like Thales. So first, I decided not to talk about transfers in terms of AI for competitiveness or AI for systems engineering, because there are a lot of possibilities there. So I will mainly focus on AI for AI systems. So AI components or AI suite of components embedded into systems for a specific customer in the end. So about current transfers, I would like to highlight something which is quite simple, I guess, because we already discussed a lot of the problems. So if we want to start, we have to probably focus on solutions where the problem are less stringent than for the others. So for example, if you go to machine learning for specific activities in terms of signal processing, for example, so embedding some machine learning capabilities into sensing capabilities, so into sensors. So this is something that is already happening very clearly, whatever the type of sensor, so being radars, optronics, or even ESMs. Maybe I would highlight one specific case we have at the time, which is specific classification functions for radars, ground-based radars, which is, we think, on the industrial side already ready, meaning that performance are there. And we are proposing that in terms of being part of the product. So it's a classification function for a radar, so it's only a small part. There is no direct integration with users. There is no direct problem of integration with a safety critical chain. So this is why we can say that, okay, we are in a level of maturity that enables us to say we are ready to sell. The fact is that now we have to sell it properly. And here, what is at stake right now, and so it depends the way we can do it, but at least for selling something, you need an ecosystem which makes, I would say, with a level of maturity which is more or less equivalent between all the stakeholders. So meaning if you want to sell something with a performance, you have to agree on that performance being probably already accepted as a reference, as what looks good for such solution within a community. And of course, being able to have all the procedural and qualification recipes to make sure that in the end, this performance could be really demonstrated, meaning tested and validated in the end. And at the time we are there, and when I say we are there, I mean that we don't have at the time, I think, the necessary reference level of what goods look like. We probably to describe, so we had example yesterday of new ways of explaining a performance with a Lipschitz indicator or things like this. But in the end, if you get a figure, the question is, what is the good figure that a community for a specific question, specific problem is agreeing on? And then if it's shared, then the only question is how can you validate that, making clear and proving that you can achieve that. I think at the time we are not there yet. So we still need to improve our collective maturity, industrial parts, assessment bodies, and of course, clients, largely speaking. So that's my first example. So we have solutions like this, sensors, so ready to be sold. Of course, there are over a large number of questions in sensors, mixing sensors, so data fusion, heterogeneous fusions, sensors of sensors, or meta sensors. So a large amount of possibilities. But at the time, we have solutions for specific functions within sensors. Second example, which is the one which is here on the slide. And I already mentioned that before, it's completely different type of topic, even if it starts with sensing and data collection. It's about information processing chain. So from the very beginning, from the data to making knowledge and then making decisions based on that knowledge understanding. So it's a different type of application. We have already developed a platform to make that real. And when I say make that real, the fact is that this platform has been experimented, tested, evaluated during a NATO exercise in late 2023, in a shadow mode, of course. But it was a really good and interesting example to understand what it takes to go to the field. And going to the field here is really to understand the different processes. So going into the intimacy of the way you, when I say you, I mean the end users are really doing their work on a daily basis. And really understanding the full scope of these three parts I mentioned here in the slide. The first one being capturing data. So first you need to understand what is this CIR, so this critical information requirements. So this is what connects you to the context. Then you have to build on that, and AI is a great enabler to do that, collecting the data that will feed this scheme of information grouping and information propagation. That's the first step. The second step is about understanding what it takes for the domain, so representation of the knowledge and making sense, so meaning transforming the information over time into some parameters, indicators that will make sense for making decisions then. And of course, at the decision-making side, here you can help with also AI possibilities, trying to understand the better course of action that you can develop, and also supporting with bringing to the view of the users the best indicators that you can choose. It's important here to say that we are not at the end of the game with such a platform. It's an attempt to understand really what it takes to go to, we say that yesterday, but we are talking about trust, but trust is something that you have to build. And the question here in that process, which has been completely designed with experts in cognition, is to understand what it takes to go there. So AI, I would say it's the enabler, the support, but still we have to define, design, and develop and experiment all these changes. And the real added value, meaning in the end what you are looking for is mastering of the cognitive workload of the users, being ready to make the right decision at the right pace, at the right time, for the right purpose. So in a word, you want to trust your platform and your environment so as to be part the best you can in the information superiority. So here, really for me, the question is, so we have the tools at the time, we are ready to propose and organize something in the operational domain. The question is really how to get the intimacy to do that on a proper basis, on a day-to-day basis, to get the data, to get the understanding, to get the domain, to get the best effectiveness ratios or the best KPI, and to get also the best representation to support the operation effectiveness.
Okay, thank you, Christophe. We will get to question later after we make this turn. So Jonas, you're like me, you're new on this platform. Jonas, with more than 20 years of experience in software development in the defense industry, ranging from embedded safety critical systems, sensor signal and data processing, software innovation, project and product lead to software engineering manager. With an electrical engineering background, you have a passion for technical leadership together with new technology, and you're currently driving SAAB's business area, surveillance AI initiatives, as well as leading a new generation of common software platforms. So Jonas, could you give us examples or one example of a development program implementing AI and the challenges and opportunity you experimented?
Thank you so much. And thank you for arranging this interesting conference here today. So my name is Jonas Lindgren, and I'm here to represent SAAB. And SAAB is a company with Swedish roots, and SAAB is a company that delivers defense products within most defense domains, from fighters down to submarines. And as we heard yesterday, I think SAAB and all other industries, we are continuously developing our systems so they become better over time, bringing in new technology through spiral development, making the systems become better. So, and AI and machine learning is technology that we are now assessing across SAAB. And I would also like to point out that, which several other industries has done, that we also consider the use of Gen AI in our development as a huge benefit. And currently we have also deployed generative AI internally, so we can use generative AI developing things using sensitive data. And also being able to set up data platforms, so we can use, we have the whole MLOps flow in control. So with that said, so today I will focus a little bit about SAAB's airborne early warning system that we can see on this picture. It's called GlobalEye. And GlobalEye has a range of sensors, and with the command and control integrated into a Bombardier 6000 or 6500 aircraft. It's a system which has a sensor range of 650 kilometers, and it's a system that monitors air, land, and sea into one solution. So it's a system producing a vast amount of data. And I think it's important to emphasize, and this was also part of the discussions yesterday and this morning, that new technology as such, we need to set it into the user perspective, and we shouldn't use AI for the sake of AI. That's very important to emphasize that. So if we put this into this perspective, so how could we assist the operator or what is happening once all these sensors on the GlobalEye system are active? Of course, the first step has been to introduce data fusion, reducing the overload, fusing data from different sensors into one common picture. And then we have introduced also assistant functions using AI. So looking into helping the operator, detecting possible anomalies and also possible threats to even enhance the situation awareness. And I would also say that we have introduced AI technology when it comes to our sensors, close to helping in the detection chain when it comes to certain cluttered scenarios where AI can make a difference. Let me just turn the page. So when it comes to AI, there's a lot of aspects to address, of course, and data is one challenge. In our case, we have had access to a lot of real data from all our sensors when it comes to these anomalies and or the cluttered detections. But data with threats is hard, and I will elaborate a little bit on that later on as well, because you get so few examples of those. So this was just some examples of the current system. And I think if we look a little bit ahead, what we are looking into now is actually building a long-term memory on ground connected to these type of systems. So we can store all mission data, and we can go back in time, and our customer can build intelligence looking back weeks, months, and years. And this can, of course, be supported by AI as well. So in this perspective, GlobalEye, and as all sensors are, they are multi-domain data generators. And we need to continue our spiral development as industry and look into new technology. Thank you.
Thank you, Jonas. And now Pooja, I don't present you, but give you the talk.
Okay, there is an image missing on my slide, I realized. Maybe it's No, I would go to the next one, Jerome.
Oh,
It's okay.
switch.
The third one. Yes, this one. Perfect.
Okay.
So just some examples
Okay.
of the. So Frédéric asked the question about two things. One is the current transfers of AI, and then the short-term or prospects of AI, which will be transferred to the industry. I have three examples from the defense and space domain. So there are no civil examples here. One is the A330 MRTT 8-way refueling. This is something that I mentioned already. It's a part of a tactical assistance during the military missions, but it is a dual purpose technology. It could also be applicable to our civil world. And this is just where we use computer vision for making a contact between the boom control unit of the tanker aircraft and the receiving aircraft. So computer vision is used here for that. And then it's also recently we proved that it is possible during the night to perform this operation. So like I mentioned before, A330 MRTT is the first tanker that is certified to perform this operation with AI technology, which is onboarded. So this is one transfer to the industry. We have some of the A330s with this capability flying around the world today. So that's one. Second, Airbus One Atlas platform that I already also mentioned, but could give a little bit of more detail on there. This is a platform where we collect the Earth observation satellite imagery coming from our satellite constellation. And we also offer digital services on top of it. These services could be for civilian applications. They could also be for military applications. Some of them are also classed as AI for good. I can give the examples of that. For instance, within the perimeter of a city, you can perform change detection to see what changed from in the chronological view, for instance. You can also do maritime ship detection in the sea and the ocean. You can also perform a lot around the agricultural landmark detection, identifying the areas of forest or agriculture. On natural, for instance, the fire detection is also possible with this type of observation imagery that is all co-located on the One Atlas platform. There is one recent feature that we rolled out, which is the image enhancement capability. We take the picture from our Pleiades Neo constellation at the 30 centimeter resolution, and then we use AI to enhance the imagery to 15 centimeter resolution. And this is a recent patented application from the Airbus space family that is now operational and is you can actually go on the One Atlas platform, create a login for yourself, and see if you want to download some images at a certain cost. Third example is the massive intelligence platform, which I also already mentioned. There are two parts to it, and this acts as a basis to the multi-domain operations that we have been talking about. Here is a platform which is a collaborative platform which combines the data coming from different sources. One big part of it is the open source intelligence coming from the web and from every medium mining that we can do. And it also provides a way of visualizing the combined insights coming from the different data sources. And if you think of in the frame of FCAS, if you think of multi-domain combat cloud as the place where we will realize the multi-domain operations, then this is actually plugging into that, acting as a baseline platform that will work in integration to that. These are some of the current transfers and from our Defense and Space Division. But I could also speak about the short-term transfers, for instance, which are now planned and in the pipeline. Like maybe I downplayed the question a little bit before, but the assistance to the pilot during the landing phase is something that we are working with the computer vision building blocks in our civil domain. Also, there are other computer vision building blocks planned for the gate-to-gate operations still in the demonstrator stage, which are also going to be the future transfers. When it comes to the military domain, mission planning systems using planning and scheduling algorithms, some of them using traditional operations research, constraint programming methodology algorithms, but some of them also using reinforcement learning. We have a spectrum there, which are in the pipeline now. For the space, something that we are also actively preparing is the onboarding of CV capabilities for object detection and collision avoidance, mainly in the space area. So some of these elements are now in the pipeline and will be soon to be transferred into the industry. So.
Okay, thank you very much, Pooja. We'll take the first question that we had together, and then I will move because we have two questions from outside. So for all these different examples, one important point is operational data to build AI models. So I had my own point of view earlier. Have you something to say about that, Jonas, starting with you?
Yeah, thank you. I think you talked a lot about those issues, but I can conclude my part as well here. So, I mean, operational data is key to train and to retrain and to validate the functionality that we are building. And of course, there are challenges here. I mean, there is a lack of operational data for the industry because of defense classifications and so on. There is this low degree of recurrence of certain threats and tactical and operational data. And then it's, of course, as you also talked about earlier here, it's about how to share data, and that was also a topic before. And I would say that, at least from what I read and understood, I think US is more open to share operational data with its industry. And I think this is something that the EU and its nations need to consider as well. And even if we are going to use operational data, we need, of course, to have the cybersecurity in place and the cloud and so on. So the need to know basis, both on the data itself, but also on the aggregated models that we do from the data from different parts. So, and I mentioned it earlier, the low degree of recurrence, and I think here the industry need to rely on simulations and having good physical models. And the operational data will help us build even better physical models. So we need those type of data to ensure that we make good systems. And of course, we will always end up, I see, in situations where we cannot share data. We don't have access to that. And we have customers that discuss that they want to be able to retrain the models themselves, as we heard earlier this morning. And of course, this would require new competencies at the end, at the customer, because they need to know and understand how the whole MLOps flow is going, and if the model is getting better, and so on and so forth. And it also, of course, addresses the challenges of responsibility and accountability when it comes to these type of situations. So, but I think to just close this one off, to increase speed in development, I think the operational data will be super important. Thank you.
Christophe, a word on this question?
No, I think you mentioned more or less something already, maybe except a fact on sovereignty, which is also key for data. So, okay, a lot of constraints, but we need data anyway. So the question is, how do we do that? And at the time, I think the best way is to go case by case and learn by doing. So in some occasions, like big programs like NGWS or things like this, there may be some opportunities to raise a few rules maybe and discuss these rules and the best way to make them live on a day-to-day basis. But for most of the time, in the end, in our different businesses, we see that case by case at the time.
I think I concur with both of the viewpoints that are expressed by Christophe and Jonas here. First is that it's true that we have a problem around operational data not being available so easily. And this actually limits a lot the type and the performance robustness of the algorithms that we can develop for specific functions. So this is a problem that exists today. And what Christophe mentioned is also very valid, that I think as an industry come together, develop a framework, specify some ground rules in place as to what and how can this data sharing happen. And if we can do it for some of the exemplary use cases that we can take as the first contenders, and then sort of develop a framework, this is what is needed today. I think there are some efforts around that, but that needs to be going into this direction a bit more. Because having operational data testing the AI algorithm within the operational environment. These are concepts which are coming together in the technology readiness levels. So you cannot prove that the technology is mature if you haven't tested your algorithm within the operational environment, or if you have not tested the algorithm on the operational data, then you have no way of proving that your algorithm has achieved TRL6, for instance. So it comes back to this question. So until and unless we tackle this point, we are just behind that technology readiness level. We are never achieving the stage where we can say this can now be operationalized, it can go on the platform. So I think it's a mindset change within the industry. We need to become a bit more open, like Jonas gave the example of the US being a bit more open around data sharing. Very true, and I think we need to reflect on these points.
Okay, thank you. I will go to the question we get from okay, there is one question which is addressed to me, but I will enlarge this. It is, it's been said that the Rafale will be the main fighter for the next 20 years. Is Dassault Aviation planning to implement an open architecture on the Rafale, or during the period the French Air Force will be stuck with AI made by the actual big players, Dassault, Thales, Safran? It's a very good question. So first of all, already in the Rafale F4, we have a more open architecture because we have a second mission computer, and we have also embedded it's not an iPad because it's not secure enough, but it's a tablet which gets inside all the mission planning software, and also in this new computer we have the simulator embedded. So we have an embedded simulation program in order to enhance the training. And inside this type of computer, we already have external algorithms that can be developed also by the French Air Force. So this is to answer on the open architecture. But then I will transfer the question to my colleagues, say how to implement the right hardware architecture, hardware and software architecture on a current platform to implement onboard AI algorithms. Because again, it's how we will not wait the next fighter in 20 years. We have to do something today. So how do you move on current platform to more open architecture for being able to receive AI functions? So that. Yesterday we have a part of answer from Thales with this dual hardware, one being edge blade with much data and CPU, and then another critical one. But have you something to say about that?
No, I don't have so much to say, but I think it's important that we can separate the safety critical part from the mission critical parts, and doing that by using hardware. And that will be the foundation for have different, so the parts that are not safety critical, they can have a higher loop time when it comes to new software updates. So I think that is crucial.
So maybe one thing once more, it's specific to any use case.
Yeah.
So obviously, but yesterday you had an example of best way to get say computing resources close to a safety chain. It's close to, because the safety checker is not part of the optimization computation for the trajectory. So this is a way to do. And by the way, we may also understand that this computing power may be on the ground if we rely on the communication link between the ground and the flying platform. So everything is possible, but it's really use case dependent. So of course, on the ground it's easier for swap constraints. It also that's also the reason why I'm more or less always talking about information processing chain, because in the end, what it takes is linked to the full chain. You can consider sensors on the side, yes, but in the end, sensing serves an operational goal. So you have to understand what it is in the end. That's the same thing for any understanding of what good automation looks like at each of these different steps in the information processing chain. So I would encourage to understand that, and it's particularly difficult when we are discussing distributed solutions, okay, like in WS with exchanges needed from the ground up to the edge and up to the far edge, if we consider the fighters and the remote carriers or even the weapons. So it's really difficult for distributed systems. And this is, by the way, the goal for the combat cloud, to solve these kind of problems in a way of trying to do the best we can with IT technologies. We know that because in a data center, for example, we are able to do that. It's scalable, it's perfect, because everything is homogeneous in terms of computing capabilities, and in terms of communication, it's more or less perfect. So we have to transfer that type of technology, and this is the goal of Combat Cloud, into an environment which is with different types of clusters, so heterogeneous clusters for computing, and also, of course, with communications that are not perfect. So we know that perfectly. So that's the challenge, but it will be a long way.
We have only 2 minutes left if you want to add something, because we have no time for the second question. So
I don't have many points to add. It's just let's develop all sit together, develop a DO-254 airborne certifiable hardware, and then put some software on it, DO-178, and then we make it fly. But no, just thinking about what we can do for the current generation, I think a lot can be done if you think about enhancing the existing systems. So there are systems already today for navigation. There's already systems for communication. If you think of enhancing those by bringing in some AI into the picture, then we're just doing the inference. We are not really training anything on the platform. So for this, it should be possible. But if you think of adaptive AI, where we are actually collecting data, learning on the go, then we are far away from it. This is clear.
okay. So thank you, everybody. Thank you for hearing us. And I think it's the end of this last roundtable. And I will let Jérôme make a conclusion for that. Or maybe Philippe and Jean-Luc.